Good morning, Senior 1. Our lesson today is about satellite. But first, we have to understand the idea behind which satellites are launched. Imagine with me, guys, that you have an object and you projected it. It moves in curved path before falling down. If you increased the velocity of projection, the projectile moves for a long distance before falling down. That is satellite. So, satellite can be defined as an object projected at a certain velocity to rotate in a circular path with constant distance from the Earth's surface. And this velocity is known as the orbital velocity. So, the orbital velocity of satellite can be defined as the velocity that makes the satellite orbit Earth in circular path at constant distance from the Earth's surface. And now, let's find the orbital velocity. As we know, the attraction force F equals G capital M small over R power 2. And also the centripetal force F equals M V power 2 over R. All of us know that the attraction force can be considered as a centripetal force. So, G capital M small over R power 2 equals M V square over R. So, V power 2 equals G capital M over R, and finally V equals root G capital M small over R, where G capital is the gravitational constant, which equals 6.67 times 10 power negative 11 meter power 2 kilogram power negative 1 to the second power negative 2. M capital is the mass of Earth or the mass of planet. R small is the orbit radius, which equals the summation of radius of planet and the height of a satellite. So, finally, we can find that the orbital velocity V equals root G capital M capital over R capital plus H. And now, let's study the factors that affect the orbital velocity V. The first factor that affects the orbital velocity V is the planet mass, where the relation between the orbital velocity and rho m is directly proportional. So, if we draw a relation between the orbital velocity V in y-axis and rho m in x-axis, we get a straight line. The slope of this straight line equals root G over R. By knowing G, we can get R from the slope. But attention, guys, we can't consider the mass of satellite as factor affects on the orbital velocity V. Again, the mass of satellite can't be considered as factor affects on the orbital velocity V. The second factor which affects on the orbital velocity is the orbital radius, while the relation between the orbital velocity V and the orbital radius is inversely proportional. So, if you draw a relation between the orbital velocity V in y-axis and rho r in x-axis, you get a curved line. But if you draw a relation between the orbital velocity V in y-axis with 1 over rho r in x-axis, you get a straight line of slope equals rho g m. By knowing g, you can get rho m, or the mass of the planet. And now, let's solve the first problem. Problem number 1. The moon rotates around the Earth in circular orbit whose radius is 3.85 times 10 power 5 kilometer. It makes a complete revolution during 27.3 days. Calculate the mass of the Earth. Okay, first, the time t, which equals 27.3, represents the periodic time. That's why, because in the problem, he said that it makes one complete revolution during 27.3 days. And we know that the periodic time is the time required to make one complete revolution. So, periodic time t equals 27.3 days. But we have to convert days into seconds. How? From the following relation. T equals 27.3 times 24 times 60 times 60. So, the periodic time t equals 2358720 seconds. And he said also the orbital radius equals 3.85 times 10 power 5 kilometer. We have to convert kilometer into meter. How? From the following relation, r equals 3.85 times 10 power 5 times 10 power 3 kilometer. So the orbital radius r equals 3.85 times 10 power 8 meter. He asked for the mass of a planet. As we know that V equals 2 pi r over t. Also, V equals rho G capital M capital over r. So, 2 pi r over t equals rho G capital M capital over r. So, M capital equals 4 pi power 2 r power 3 G t power 2. And finally, we get mass, which equals 6.07 times 10 power 24 kilogram. From this problem, we can get that the periodic time t power 2 is directly proportional to r power 3. Again, t power 2 directly proportional to r power 3. The importance of satellites or the types of satellites. The first one or the first type of satellites is the communication satellite. Second type, astronomical satellites. Third one, remote sensing satellites. Number 4, spying satellites. And finally, weather satellite. Attention guys, if the satellite stopped and its velocity becomes 0, satellite will move in a straight line under the effect of gravity of the Earth toward the Earth and fall down. But if the gravitational force between the Earth and the satellite becomes 0, the satellite will move in a straight line, tangent to circular path away from the Earth.